right, so the goal is when we finish your notes, then I'm going to give you back some more papers. I'm going to give you a new progress report. When is the last day for late work? Did I already talk to you all about it? Okay, Wednesday. What also is on Wednesday? Early release. Your test is the day before, though. Yeah? Okay. So we'll do a review. You'll get it on Friday. We'll review on Monday, and then you'll take your test on Tuesday. Okay? So a composition of functions, in case you don't remember, we did this a little bit in the fall just now with trig. That's when you have a function inside another function. Okay, do you remember which one you start with? Outside or inside? Inside. So you're always going to plug into the inside function first, and then do the outside function second. So if you know how to do your unit circle, this should be easy. Okay? So here's my unit circle. First one, I want to find, actually we're going to skip, we're going to do this one first. Okay? And actually, it's not even going to work. Some of these aren't looking so good. Let's do number 6 first. Okay, we're going to start bottom half. Okay, so inside function is what I'm going to do first. So look right here. I want the inverse sine of root 3 over 2. Look at your circle. This is what we've been covering for a while. Okay, root 3 over 2 should be the x or the y. If it's inverse sine. Y value. Okay, so where on the circle is my y value going to be root 3 over 2? Okay, pi thirds and 2 pi thirds. Then what I'm going to find is the cosine of pi thirds and the cosine of 2 pi thirds. Does that make sense? Okay, so you're going to take what the middle is. This is either pi thirds or 2 pi thirds. And then you're going to plug both of those answers into the outside function, which is a what? Cosine. Yeah, well, not in the calculator, on the circle. So pi thirds is here. Cosine is the x value. What's the x value? A half. 2 pi thirds is here. What's the x value? Negative a half. So this one would be a half. This one would be negative a half. And you're done. Okay? All right, let's do another one. Let's do number 7. Number 7, I want the inverse sine of minus a half. Sine is an x or a y value?
Y.
Sine is a y value. I want minus a half on my circle. Where do I have minus a half as a y value on the circle? And 11 pi 6. So write those down. 7 pi 6 and 11 pi 6. And then what am I going to plug each of those values into? Well, this is, okay, secant, which is cosine flipped. Good. So I'm going to do the secant of 7 pi 6, and then I'm going to find the secant of 11 pi 6. And then remember, secant is going to be cosine flipped. Now, the other thing, too, is remember, since you're doing the same angle, you're staying at the same part on the circle. Okay, so if I want 7 pi 6, that's here. Cosine is the x, so if the x is negative root 3 over 2, what is that if I flip it? Negative 2 over root 3. Can I leave it like that? No, but it's an easy fix. I'll put a root 3 top and bottom, then I'll be done. So root 3 here, root 3 here, negative 2 root 3 over 3. Okay, let's do the same thing for 11 pi 6. For 11 pi 6th on my circle, put this back up in a second. 11 pi 6th is here. What's my x value for cosine? Root 3 over 2. If I flip it, what would I get? 2 over root 3, but this time it's positive. And then remember, I just fixed that. My answer is going to come out the same. I put my root 3 top and bottom, and I'd have 2 root 3 over 3.
Are you always going to flip them?
Only if it's secant or cosecant. Those are the only two where you have to go back to sine or cosine and flip. Okay? Does that make sense? 2 root 3 over 3. 2 root 3 over 3. I feel like y'all can't see those. Okay? Let's do the one right next to it. Next one, I want inverse secant of 1. Secant is which one flipped? We just did it. Cosine. But remember, if it's on an inverse, you flip the number part. What is 1, though, if I flip it? Still 1. Think about 1 is 1 over 1. If I flip that, then I just still get 1 over 1. It stays the same. Okay, if it were a negative 1 and I flipped it, what would I get? Still negative 1. Okay, so remember, 1's just stay the same. Okay, so I'm looking on the circle for where inverse cosine is 1. Look on your circle, cosine's an x or a y. Which one?
X.
Cosine's x. When is cosine 1? 2 pi and 0. Remember, they're the same, but you have to list both of them. So this is going to happen at 0 and 2 pi. And then what am I going to plug those values into? Cotan. So if tan is sine over cosine, then cotan is going to be cosine over sine. Okay, so look on your circle. What's the cosine of 0? Cosine of 0 is the x value at 0, which is 1. And then what is the sine of 0 on the circle? Okay, sine of 0 is 0. Can I do 1 divided by 0? No, it's undefined. What about for 2 pi? It's the exact same place on the circle, right? If it's the exact same place on the circle, then I'm still going to get 1 divided by 0. Can't do it. So it's going to be undefined for both. Okay, because remember, these are the same place on the circle. Okay, it's called two different things, but you're at that exact same ordered pair on your unit circle. Okay, one more like that. Take a look at number 5. We want the inverse cosecant of negative 2 root 3 over 3. Cosecant is which one flipped? Inverse sine, but then I have to take my number and flip it. So it's going to be 3 over 2 root 3. Okay, so remember, you're flipping the number when it's an inverse. Okay? And then from there, think about that's not on my circle, but it's because it's breaking a rule. What rule is it breaking? Can't leave the root 3 on the bottom, so I'll put it on top and on bottom. I'll have a negative root 3 on top. On bottom, what's root 3 times root 3? And so that's a 2 times 3. Well, then what's going to happen? 3's cross out. What angle are they really wanting? Negative root 3 over 2. So let's find the inverse sine of negative root 3 over 2. Does that make sense what happened? So I did root 3 times root 3 is a regular 3. And then that's going to knock this 3 off the top to where I'll just have the square root 3 and the 2 left over. Okay? Sine is a y value. So look on your circle. When is your y value negative root 3 over 2? It should be on the bottom half. Okay, yeah, one of them's at 4 pi thirds. Where's the other one? 5 pi thirds. So 4 pi thirds and 5 pi thirds. So that's going to be 4 pi thirds and 5 pi thirds. Okay, and then what am I plugging those into that was on the outside? Tan, which is sine over cosine. So then I'm going to find the tan of 4 pi thirds. And then I'm going to find the tan of 5 pi thirds. Okay? And then as Amaya said, tan is sine over cosine. Okay, so look on your circle at 4 pi thirds. What is the sine of that value? It should be the y value. Negative root 3 over 2. What is the cosine? Negative 1/2. And then remember, dang, I wrote too big. But remember, you take the 1/2 and you flip it. So what's going to happen, I'll just write it on the board here. If I have negative root 3 over 2, but I multiply it by a 2 over 1, I'm going to get negative root 3 for my answer. And on the other one, it's just, it will be positive. Thank you, I forgot. This was a minus 1/2. So when I flip it, it's a minus 2 over 1. So my negatives cross out as well. So I would get positive root 3 over 1, which is really just root 3. Now, quick question. What's the only thing that's going to change when I go from 4 pi thirds to 5 pi thirds? My y is still going to be negative root 3 over 2. What's my x going to be? Positive 1/2. And if I divide those out, I'm going to get the same number. The only thing that's going to be different is the negatives won't cancel anymore. So for this one, it's a positive root 3. For that one, it's a negative root 3. Does that make sense? The first part or the second part? So the middle part is what we did yesterday. So are you good to there? And then this part is what we did last week. So it's like you're just putting them together to be 2 steps. So I find the inverse sine of negative root 3 over 2. I get 2 places on the circle. And then I find the tan at both of those 2 places. Okay? So let's do one like that off your homework, which I forgot to pick up. Let's do number 9. Okay, look at your homework. Number 9. Okay, I'm going to give you a second to think about it. I want the inverse cosine of negative root 2 over 2. Just do that part first. Are you looking for an x or a y? An x of what on the unit circle? Negative root 2 over 2. So where does that happen on the circle? Okay, so negative root 2 over 2 is here at 3 pi fourths. And also down here at 5 pi fourths. So 3 pi fourths, 5 pi fourths. Okay, what do I plug both of those into though after that? Sine. So I'm still looking at that exact same place on the unit circle, but now if I want the sine, then I'm looking at the y value. Oh, did I write the wrong number? It should be 3 because remember cosine you're looking for a negative x value. So like here I want negative root 2 over 2. So that would be at 3 pi fourths. And then my other negative root 2 over 2 is at 5 pi fourths. At 7 pi fourths, what's your x value? Positive root 2 over 2. So we're looking at the x to be negative. Okay? And then from there at 3 pi fourths, which is right here, what's my sine, which is my y value? Root 2 over 2. And then what about for 5 pi fourths? What would that be? Just negative root 2 over 2, because I'm down here at the bottom of the circle. Make sense? Okay, let's do one more that's kind of easy like that. Why don't we do number 10? What's the cosine of pi? Look on your circle. Now, notice on this one that your first thing is not an inverse. Cosine pi, what am I finding on my circle? Okay, I'm finding the x value. So cosine pi, as you guys just said, the x value is negative 1. But then what do I plug negative 1 into? Inverse tan. Now, remember, tan is sine over cosine. What's the only way that sine over cosine can come out to be 1? Do you remember? Root 2 over 2, divide by root 2 over 2. Now think about why. If I want two things to divide to be a 1, then they had to be the same. Now, do I want them to be same signs as well? If I want a negative 1, they have to be opposite signs. So look on your circle. When are x and y both root 2 over 2, but only one of them can be positive, not both? Where? Yeah, so it should be 3 pi fourths here. And then remember, in this quadrant, they're both negative. So then I would want 7 pi fourths. Yeah? So 3 pi fourth and 7 pi fourth. Okay. Okay, let's do number 12 off your homework. Let's try to knock some of these out. So I want the secant of 3 pi fourths. What am I going to find for secant and flip? Okay, I'm going to find the cosine of 3 pi fourths. Then I'm going to flip it. So go to 3 pi fourths on your circle. What is 3 pi fourths on your circle? I want the x value for cosine. Okay, so 3 pi fourths is here. I want negative root 2 over 2. That's my x value. But then I'm going to flip it so it'll be 2 over root 2. Make sense? Okay, then from there, I'm going to go ahead and fix it. Root 2 top and bottom. Which means that really I want negative 2 root 2 over regular 2. But what happens when we do that? Really, I just want negative root 2. So negative root 2 is my answer from the middle. What am I plugging that into? Cosecant with a negative 1. And if it's a cosecant, what do I have to flip? So it'd be the inverse sine of this flipped. Now, quick question. I fixed this before, but if I had left it like this, when I flip it, is it already fixed? Think about it. If I had just left it a negative 2 over root 2, even though I'm breaking the rule, think about it. If I'm about to flip it back, then I'm just going to flip this. You see what I'm saying? Like, we fixed it to follow the rules, but now we're just going to have to fix it again. So if this is the angle I want, and I flip that, it'd be negative root 2 over 2. And then where on your circle is inverse sine negative root 2 over 2? Sine is a y value. 5 pi fourths and 7 pi fourths. Because they both have to be negative on the bottom. That's okay. Let's do this one. Inverse cosine 0. Where is inverse cosine going to be 0? Okay, cosine is going to be 0 when x is 0. That happens in 2 places on the circle. Where are they? Pi over 2 and 3 pi over 2. So my middle part is going to be pi over 2 and 3 pi over 2. But then what do I have to plug both of those into? Cotan, right? So cotan is going to be cosine over sine. So if I want cotan of pi halves, that's going to be cosine divided by sine. What is the cosine of pi halves? 0. What is the sine of pi halves? What is 0 divided by 1? 0. Now let's do 3 pi halves. Cotan of 3 pi halves is going to be cosine divided by sine. What is the cosine of 3 pi halves? What is the sine of 3 pi halves? Negative 1. What's 0 divided by negative 1 though? Still 0. So they just come out to match on that. Make sense? Okay, go back to your notes. Several of these on your notes look like they might not work, but let's try it. Okay, let's look at number 1. Okay, look at your middle part. Tan of 3 pi fourths. How am I going to find the tan of 3 pi fourths? I'll do sine divided by cosine, right? That's how you find sine. Now notice, why am I not doing an inverse? Because the middle doesn't have the little negative 1 on it. What is the sine of 3 pi fourths? Positive or negative root 2 over 2? Okay, positive. What is the cosine of 3 pi fourths? Negative root 2 over 2. And then remember, when I divide root 2 over 2 by itself, I'm going to get a 1. Will it be a positive or a negative 1? Negative 1. What am I going to do with negative 1 next? Plug it into the outside function, which is cosecant. And remember that cosecant is sine. I just have to flip the middle. But what's negative 1 if I flip it? Still negative 1. So remember that if I want cosecant, flip negative 1, and it stays negative 1. So I want inverse sine of negative 1. Where is inverse sine going to come out to be negative 1? Y value 3 pi over 2, yep.
Oh, I see 3 root.
And remember, sine is the y value. That's why I'm looking at that bottom part on the circle. Make sense? Okay, number 2 is super easy. What happens when you put an inverse sign on a sine? They cancel out, and you just keep the middle. So if it ever comes out to be the exact same function, you already have your answer. Okay, only if it's the same type though. Like an inverse sine and a cosine, those don't cancel out. Okay, but if it's the same type. So does that happen on your homework anywhere? Nope, sad. Okay, let's do number 4. How do I find the secant of pi? I look at pi, I'm going to find the cosine and then flip it, right? So look on your circle, what's the cosine of pi? Negative 1, but what's negative 1 when I flip it? Still negative 1. And then how do I find inverse tan? If I want it to be a 1, sine and cosine need to be what? They both need to be root 2 over 2. Same sign or opposite signs though? Opposite. One needs to be positive, one needs to be negative. And if you remember, all students take calculus, right? Okay, if I'm in this quadrant, everybody's positive, I know I don't want that. In tan, I don't want it because sine and cosine are both negative. Then I know automatically that I want these two. So 3 pi fourth and 7 pi fourth. Does that make sense? Okay, one more left. Negative pi 6. Remember, you just rotate the other direction. You're going to rotate down. So if I'm at negative pi 6, that would just be here. And then if I want the sine of that, is that what it said? The sine of that, what would I want? The x or the y value? Which is negative 1/2. Then I want the inverse secant of negative 1/2. How would I find the inverse secant of negative 1/2? I would have to change that to a cosine and then flip the number. So I would have the inverse cosine of flip negative 1/2. What do I get? 2 over 1. And is that anywhere on your circle? No. Okay, your x value never comes out to be 2. It can be 1/2, it can be 1, it can be root 2 over 2, but it's never going to be a 2. Okay, so that's not possible. I think we had a couple on the homework yesterday where that happened. Okay, you want to do like 2 more off the homework? You want to pick? Three? That's the one I was thinking of. Okay, look at number 3. Okay, for the tans, I would just try to remember which one's which. If I want root 3 over 3, do you remember which one needs to go on top? Good, that's right. Okay, it'd be 1/2 over root 3 over 2. And then remember why that happens. If I put the half on top and I flip the bottom, then I get 1 over root 3, but then I have to fix it. That's why it looks like this. So 1/2 has to be on top. Root 3 over 2 has to be on bottom. Remember, sine is the y value. Cosine is the x value. I need it to come out negative. Where am I looking at on the circle? Sine needs to be 1/2. Cosine needs to be root 3 over 2. Do I want this one? Sine is 1/2. X is root 3 over 2. If they're both positive, that's going to come out to be a positive. I want a negative. So I'd have to pick not pi 6, but 5 pi 6. Would I want the double negative pi 6? But I would want the 11. Make sense? So the middle of that is going to be 5 pi 6 and 11 pi 6. And then once I get those answers from the middle, what am I doing with them? I'm taking those numbers from the middle and now I'm going to plug them into sine. So then I'm going to find the sine of 5 pi 6 and the sine of 11 pi 6. And then you would just do that on your circle. Okay. So 5 pi 6, we already found it was over here. What's the sine of 5 pi 6? 1/2. What about 11 pi 6 over here? Negative 1/2. Good job. So this one's 1/2. This one's negative 1/2. Okay, one more. Sure. 8. Okay, inverse cosecant, I gotta flip the number and find which function for cosecant. Because remember, I'm just looking at the middle first. Okay, root 3 over 2, I have to flip it, but then who's cosecant's buddy if I flip the number? Sine. So on my circle, I want to find when sine is negative root 3 over 2. That's a y value. Look on your unit circle for a y value of negative root 3 over 2. Where does that happen?
4 pi thirds.
Okay, 4 pi thirds and 5 pi thirds. And then what do I do with those guys? Find the cotan. So I'll find the cotan of 4 pi thirds. Then I'll find the cotan of 5 pi thirds. Now, how do I find cotan? Do you remember? Cosine over sine. I already found the place on the circle. So if I'm on 4 pi thirds, that's here. What's the cosine of that point? And what's the y? Negative root 3 over 2. So I have negative 1/2 over negative root 3 over 2. And do you remember what that comes out to be without resolving it? It comes out to be root 3 over 3. Do you remember? Okay, so once you do enough of them, I mean, you could refigure that out again. But once you kind of start doing it, you'll just remember. Now, what if you had to work it out? You'd have 1/2 times 2 over root 3. These guys cross out, 1 over root 3, and then fix it. Okay, you can figure it out every single time if you want to. Okay? Yeah, so it'd be root 3 over 3. Now, cotan, what's going to be the only difference? For 5 pi thirds.
Just going to turn out negative.
Yeah, my top is going to be positive, but my bottom's going to be negative. So it'll just be negative root 3 over 3. And that should always be true, that you're either getting the same answer twice or you're just getting opposites of the same number. Okay? Good job. Okay, also if you're feeling like this is a lot of steps, there's only 1 or 2 of these on your test. Okay? And then I told you your test is on Tuesday?
Yes.
So we got next.
On Wednesday, yeah. Huh? 4th. That's right.
Tuesday.
Sure.
Hey,
Huh?
what is Super Tuesday?
Hey, will you go down to Coach Cannon and give him my money? They're doing like a lunch thing.